It is my distinct pleasure to introduce to you the moderators of these interviews. First of all, the IEF President, Clay Mowry. I would ask him to already take a seat over there. And the IEF Vice President for Academic and Science Relations, Tanya Masson-Swan, on that side. But before kicking off the series of interviews, it is my great pleasure to welcome on stage here for a welcome message to you, the President of the Italian Space Agency, ASI, Professor Valente, Teodoro Valente. Please, the floor is yours.
Thank you. Good afternoon to all of you, dear delegates, dear guests. Welcome to the 75th International Astronautic Congress in Milan once again. This fourth plenary session with the heads of a space agency, you see, oh, they are not more on the screen. Anyway, and leaders, this represents a significant milestone in the annual AAC agenda. Furthermore, this year marks an historic event as the International Astronautic Federation, in collaboration with the Italian Space Agency, has organized the fourth AIF Global Space Leader Summit, which will be held behind closed door tomorrow. Therefore, today's meetings represents a unique opportunity to receive preliminary insights from you, esteemed leaders. The passion of space exploration, our passion for space exploration, is not merely our profession. It's a deep passion that guides our lives. And the space economy has emerged as a pivotal force, propelling the advancement of the global economy. It's imperative that we efficiently communicate the significance of space application both to the general public and to our policymakers, demonstrating the tangible contribution of our sector to the development of our communities and society across both developed and emerging nations for peaceful purposes. Unfortunately, as we well know, the current international landscape has tension, conflicts, and various challenges, but nevertheless, fully in line with the core principle and values of the AAF, we are deeply convinced that the international space cooperation and the fostering of mutual understanding are essential for our common success. And for us, space community, success embodies inspiration, innovation, scientific progress, technological advancement, inclusion, diversity, equity, and sustainability as the motto of this AIC. As you listen to the insights shared by Head of Space Agency, I encourage you to reflect on these fundamental keywords. May your engagement be fruitful, and let's bear in mind the theme of our Congress, which is Responsible Space for Sustainability. Thank you very much.
Thank you very much, Professor Valente. Before we dive into the first interview, let me just tell you that you will have the chance to also address your urgent questions to our heads of agencies by using our Slido system. And you should have a slide here that explains to you how this should work. Here you are. And please, when you put in a question, just indicate to whom you would like to address this question. But now, without further ado, it is my great pleasure to put the spotlight on the first interview on our right side, the Director General of the European Space Agency, Josef Aschbacher, interviewed by Clay Mowry.
Thank you, Christian. Appreciate you joining us on stage here, Josef. I've got a few questions for you, then we'll open it up to Slido. But let's start with Earth observation. We've been talking a lot about sustainability here this morning. You've had success with Copernicus. You've got the Earthwatch mission. What's coming up next? What are the challenges? What are the technologies that ESA is working on to talk about how we do sustainable for life here on Earth?
Oh, thank you. Is it working? Yeah. Oh, thank you, Clay, and very happy to be here for this very nice format of interviews of head of agencies. Earth observation, of course, this is a strength of ESA. Personally, I've been involved a lot in Earth observation. I used to be director of Earth observation before becoming Director General of the European Space Agency. And we have really built up a very strong program which has different facets. Is it working? Yeah. Different facets. One is the Copernicus program, which is an operational program where we deliver on a routine basis literally terabytes of data every single day. About 350 are disseminated to the world every single day for free of any place in the world. So this is quite a service we do. We offer for humanity, for humankind, to use this data and to understand better climate, use it for agriculture, use it for many applications. But also the research missions called Earth Explorers, they are quite unique. One of the more recent highlights we had was AELOS measuring wind speed in cloud-free atmospheres. But also we have just launched EarthCare, which is a mission together with Japan, with JAXA, which has a cloud profiling radar and really measures the radiation balance of our Earth system. So we have a lot of data, a lot of missions that are quite, I would say, quite good and to really understand better our planet. But the next step really is to use this data and not just measure and really convert data into information, to model our Earth system and making sure that we can use our data to better understand the Earth system, our planet, but also to model eventualities in the future. We call it Digital Twin Earth, where we really turn some of the handles or some of the parameters to see some extremes. What happens if one parameter changes this way or the other way? So the next big step really will be, and this is where we engage in ESA and also at European level, is to, of course, keep continuing measuring all these observables from our satellites, but also really convert it and go the next step. That means artificial intelligence, Earth system modeling digital twins to really better understand how we can use all these space powers we have for the benefit of our planet.
Thank you very much. You know, space is getting more crowded. You know, about a decade ago, we'd had about 1,000 active satellites in orbit. Now we have several times that number. I think in January, when I saw you in Brussels, we were talking about something like 40,000 satellites will be active within the next decade, more than that. You guys have a zero debris policy. Can you talk a little bit about that, what ESA is doing to try to promote that sustainability aspect of the in-space environment?
Yeah. Oh, this sustainability, you just asked me about sustainability on Earth and what our Earth observation program is doing. Of course, there we really use our satellites to support sustainability on planet Earth, so climate change, agricultural, environmental monitoring, many of these activities. But of course, also in space, we have to look at sustainability, and this is exactly what we are doing with our Zero Debris Charter, but we have also other related activities that are dealing with sustainability of our Earth orbits. As you say rightly, we have today more than 1 million particles larger than a centimeter that are flying up in the orbit, debris, and they are quite dangerous. If one of them hits one of our spacecraft, or leave alone our astronauts, of course you can imagine what this means. This is life-threatening, or certainly threatening our infrastructure. So one initiative I took with our member states is to propose this Zero Debris Charter, which is a very simple charter, a very simple principle, which basically says that whoever is launching a satellite, if you sign this charter, you commit that you take it out of the orbit at the end of its lifetime. I think one would say this makes good common sense. That's exactly what it is. So we have proposed and we have elaborated this charter with 40 organizations. So it's not an ESA charter. We have held the pen, if I may say so, but it's really different organizations who have contributed. And we have put it on the table. It was decided by our ministers as something that we should pursue and attract other agencies and companies to join. And I have to say, I'm quite impressed and quite surprised, actually, how big the interest on this charter is. We actually have a signature event later today, After this signature event, where we expect another few dozens of signatories, we have more than 100 signatories signing up on a voluntary basis, because we are a space agency. We are not a regulatory body. We are not enforcing it, but we really call on all agencies, partners to voluntarily adhere to these principles, which are very simple. So I'm really grateful to all the signatories for joining this initiative. It's, I think, a marvelous initiative, and it really shows that I think we're pushing the right buttons here, because there's such a large interest. Of course, we have many signatories from Europe, but also the United States. We have some private companies from the United States who have signed up to it. One of them, if I may mention, because they are published, is Amazon. Amazon, through the Kuiper constellation, will adhere to the same principles to deorbit satellites at the end of the life. But also some countries, of course, European countries. Later in the afternoon, we will get Mexico and New Zealand to sign the charter, in addition to many other private companies or institutions who have done so already. So 100 so far. It keeps increasing. I get a lot of interest from many countries. I would like to thank every single one to sign up to it. We will have other signature rounds. Actually, the next ISC in Australia, we are planning again to focus on the Asia-Pacific region. So really, it's quite amazing, and I think very encouraging that so many are, as I say, voluntarily signing up to these principles. I think it's great, and I really would like to thank every single one from the bottom of my heart for this responsible act they're having.
Thank you. The next question is a bit ominous. It's about, yes, please. Well done, well done. My next question sounds a bit ominous, but perhaps not. It's the anticipation of cosmic threats. So ESA has several programs, the Hera, the Ramses. You have some efforts in space weather, Vigil. We just had some amazing northern lights in the US, all the way down south. You could see them very far because of this coronal mass ejection that's happening from the sun. Talk a little bit about what's happening on cosmic threats.
Yeah, cosmic threats, or we call it planetary defense, is also another new domain which we have initiated. We have a number of activities. One is space weather. Vigil is the mission that looks at the outbursts of our solar body, all the solar flares that, as you just mentioned, sometimes cause wonderful northern lights going all the way south. But also they are threatening our infrastructure. They are threatening our infrastructure in space, but also on the ground. And of course, there we need to have early warnings. We do this together with NASA. We have one mission called Vigil, which we will position on Lagrange point 5, and together with a NASA mission, we will be in a much better position to really see the oncoming solar flares and therefore warn our infrastructure operator, the population, much earlier of what's going to happen. But you mentioned Hera and Ramses, and I have to say these are quite fascinating missions. Hera we launched just a few days ago, last Monday. Good luck to NASA for your launch, which was very closely tied with others, of course, for a different purpose, going to do the Jupiter icy moons. But we have Hera launched last week, and this is a mission that is looking at the asteroid that was which was observed first by the NASA DART mission, and then had a kinetic impact to really hit Dimorphos with the satellite itself, and change its orbit and change also its configuration. And this is quite impressive. It happened, of course, very far away from our planet Earth, so therefore our planet is very safe. But of course, if such an asteroid would come closer to planet Earth, our question is, in terms of planetary safety, planetary defense, what would we need to do in order to help our planet, to help humankind not to be impacted by such an asteroid? And it's quite interesting what this mission will measure. It certainly looks at the impact of DART. We know, or we expected actually, or NASA scientists together with our scientists expected that the orbit of Dimorphos around Didymos will change by 2 to 3 minutes through this impact. The reality was it has changed by 33 minutes, so you really see that the impact was much larger than was anticipated. We want to understand why. What is the composition of Dimorphos? How did this impact the asteroid? Did it crack it up? Is it just a crater? All the debris, that means all the rocks that are flying around with it still, because there is gravity of the asteroid, how do they behave, and so on. So there's so many questions which we do not know, and this is exactly why Hera is launched in tandem with DART to really inspect how this could work. And this, okay, we will come to this asteroid in about 2 years' time. But the science and the understanding of this asteroid will be quite important for another asteroid that comes to our planet Earth, literally quite close, called Apophis. Apophis is predicted to come to our Earth, and it's actually coming within the arc of the geostationary satellites. That means below 35,800 kilometers, and will pass by Europe and Africa, and then hopefully disappear and continue. So we really would like to study this object from close by. So we have just decided a few months ago to launch another mission to get ready for this Apophis asteroid called Ramses. And there I would like to thank our international partners who have also expressed indications that they would like to join us, in particular, again, NASA, also JAXA, India, to be confirmed. So really, this is something where we have an international mission which, in order to really investigate that. That asteroid Apophis will come to our planet Earth on the Friday the 13th. The Friday the 13th of April ominous. 2029, and we really would like to see what happens there.
Okay, thank you. It is, so it was a bit ominous. Huh? I mentioned in the opening ceremony the success of Ariane 6 on its inaugural flight. You and I were talking about Vega C. Can you talk a bit about sustainable European access to space? What does this mean?
Oh, European access to space, something that really occupies me a lot. As I said before, I'm not coming from the launch domain in terms of education and experience. My background is Earth observation. But when I became Director General of ESA about 3 years ago, of course, my first challenge was Ariane 6. It was in the midst of its development, and to make sure that we get it safely to the launch pad as quick as possible. I have to say I discovered quite some technical problems, some management issues that needed to be sorted out. So I really was focusing my attention on getting Ariane 6 onto the launch pad. But in the meantime, we still had Ariane 5. So Ariane 5 had a few more flights, but we had a gap between Ariane 5 and Ariane 6. And this, of course, is something that I really made very clear to the public, that Europe cannot have no access to space. So we do need guaranteed access to space. And this was a warning call, a wake-up call for all of us, that we need to really focus on that. So we have decided, and thanks to the member states, quite a number of steps. On one side, of course, getting Ariane 6 onto the launch pad as fast as possible. And I can say the last 3 years have been very intense to make this work, and thank God successfully. Also, Vega C, we get it back to flight, return to flight by the end of this year. And in parallel, member states have decided that we will change gear. There's a paradigm shift, which we have agreed, a bit like the model followed in the US through the COTS program, that we as public institution, as ESA, we will buy launch services from private companies. We have a few of them in the making in Europe, micro-launcher companies, and I would like to develop them to really build up from micro-launchers to medium-sized launchers to large launchers. Of course, this takes time, but this is the new model we are implementing in Europe. Of course, now we have a transition phase between the existing launchers, Ariane 6 and Vega C, and the new ones to come through a challenge, and this will be quite exciting times.
Super duper. Thank you so much. Appreciate your time. Thank you for joining us.
Thank you.
Thanks a lot to the Director General of ESA. And now we change spotlight to our left side. From your seat, the right side, is our great pleasure to welcome on stage the Administrator of NASA, Senator Nelson. Tanya, the word is yours.
Thank you, Christian. Welcome, Administrator Nelson. We're very excited to have you here and to hear also a little bit about what NASA is doing and planning and achieving. We're going back to the moon with humans. Could you tell us a little bit about whether the plans are still on track? What are you hoping to learn, and what will it teach us about perhaps going onwards further into Mars?
Well, thank you for this opportunity. We are going back to the moon, not just to go to the moon. We did that a half a century ago. We're going to a different part of the moon. Before, the equatorial range of the moon. Now we're going to the South Pole. We think that there is water there. We know there's ice in the crevices of the rocks that are in permanent shadow. And if there is ice, and if there is further water in abundance, then that opens all new opportunities of hydrogen and oxygen. So we're going to a different part of the moon. We're also going in a different way. We're going with our international partners, and we're going with our commercial partners. And so just yesterday, SpaceX had the very successful fifth launch as they developed this very large rocket that has about 16 million pounds of thrust at liftoff. And this was another one of the steps in the iteration of developing that, of which they will join us in lunar orbit. Our astronauts will then transfer into the SpaceX lander and later a Blue Origin lander. So we're going to a different part of the moon in a different way with new partners in order to learn how to live in that environment, how to create, how to invent, how to do all of the things that we have to do to go all the way to Mars. The moon is only 3 or 4 days away. Under conventional propulsion, Mars is 6, 7, 8 months away. And then if it took that long, the planets are not realigned in such that you could get back in 6 or 8 months. You might have to wait there for a year or two. So it's going to be quite an extensive preparation, and that's why we're going back to the moon. You ask about the schedule. The schedule for the first lunar orbit or circularizing around the moon is Artemis 2, and that's scheduled for September of next year. And then for the first landing would be on a schedule about a year later, after that in late 2026.
Exciting. A lot is happening, and I'm sure all of the people here in the room were watching that launch yesterday. That was totally mind-blowing, and of course, every little step we go a bit further. Now, a few years ago, NASA and a few other partners launched the Artemis Accords, and that has been seen an exponential growth, because I think it's now nearly 50 countries that have signed up, and of course that's also very impressive. I'm a space lawyer, so I look at the Moon Agreement, which is now, you have exceeded almost 3 times the number of parties to that agreement. So could you talk a little bit about the Artemis Accords? What does it mean, and what is the intention of these principles?
Thank you for that. The Artemis Accords are a declaration of the peaceful purposes and intent with which you explore space. It is simply that. It names a number of things, such as the scientific research will be done for peaceful purposes, that you always look out for others that are exploring in space, and that you don't violate their particular experiments, that you come to each other's aid in a rescue attempt, that something would be wrong and someone is having difficulty in space. And thus, you have similar kind of materials and equipment so that you could come to somebody's rescue. The whole intent is peaceful uses of space. And because of that, I think in increasing numbers, nations are signing, joining the original 8 nations that signed up a couple of years ago.
Wonderful, and that indeed translates that whole new landscape that we're into now. And perhaps as a follow-up question, indeed, as you mentioned, it's not only the space powers who have signed up and who are eager to cooperate with NASA, but also the so-called emerging spacefaring nations. So where do you see a common ground, and how can they be involved?
The common ground is, do you want to explore space, and to do it peacefully? And I think, for example, the first two African nations to join were Nigeria and Rwanda. Here at this conference, I've met the new head of the African Space Union, and I think you will see many more of the emerging nations to join.
Exactly, so it's an exciting opportunity to involve all of humankind, and that is indeed a big game changer from the Apollo era, of course. And in your time as NASA administrator, how have you seen the world or the space field evolve? Could you draw us, make a drawing of the changed landscape that you've seen emerge?
We are in a golden age of space exploration. We're seeing so many other nations that are now involved in space exploration. We see the exploding of technology that are allowing us to do new things. I draw your attention to the James Webb Space Telescope, positioned 1 million miles from Earth on the opposite side of the Earth from the sun, always scanning, looking out into the vastness of space. And the discoveries are rather extraordinary. The discoveries are, we're answering questions that we don't even know what the questions are. We are now peering back in time almost to the very beginning. The capture of light from the formation of the first galaxies. And that was only about 290 million years after the very beginning, or about 13.5 billion years ago. Think about how long a distance that is. Light traveling at 186,000 miles per second, and that light of those first galaxies is traveling for 13.5 billion years. That's a long distance.
Makes us young.
It makes us also wonder at the vastness of this cosmos. And so these are the kind of things. Joseph already talked about hitting the asteroid in our mission DART, and they're going to measure specifically with their instruments just how much it was moved. But we now actually have the ability, proven, that if we could detect a killer asteroid far enough away, we could get to it and hit it and nudge it on its trajectory, so by the time it got to Earth, it would miss us. We went and snuck up on another asteroid, Bennu, and had an arm go out and sucked up a whole bunch of material. That material is back in the United States now, and we are examining that. And we are finding unusual chemicals, chemicals that would suggest the formation of life, even on a rocky asteroid. All on Mars now, we have a rover called Perseverance. It is drilling 32 tubes about the size of a cigar, sealing them in a titanium container, 32. We're now trying to figure out about going back, something that doesn't break the bank, by the way, because it's very expensive, and retrieving those and bringing them back. And that's from a dry lake bed where a river used to flow into that lake. And we want to see what those samples contain, if they indicate that there was life on Mars millions of years ago. We constantly are looking for life in the cosmos. We have follow-on telescopes to the James Webb that will even further allow us to identify exoplanets and possibly their atmospheres. So when you say what has changed about space, not only the people participating as indicated in this room, not only the nations of the world, but the new technologies that are bringing us greater understanding of who we are, where we are, and what we are in this vastness of the universe.
That's a beautiful message, and I'm sure everybody's listening closely. We should do that together, and the fact that you also refer to cooperation between the agencies shows that that is what is being done. On Slido, we get a lot of questions, of course, and I'll pick one of them in view of the time. How can NASA also contribute to the development of technologies to deorbit debris or to deal with the congestion of space? And perhaps that's the one I picked because of also the theme of this Congress, which is also focusing on sustainability. Can you say a bit about that?
Not only what NASA is doing, but what the nations of the world, first of all, insisting on satellites that are being put up, that they have the capability of being deorbited so they don't stay up there as defunct satellites. And certainly not the military use of space where you would shoot at a satellite to disable it and it would blow apart into thousands and thousands of pieces and all kind of space junk. On the International Space Station, from time to time, we do, in fact, have to move the space station into a different orbit to miss a lot of the space junk that is up there. So there are many things. There are new technologies that are being developed in order to try to help us get some of that space junk down. And it's important that we take this very seriously because it's getting very, very congested up there.
Thank you very much. And thank you very much, Senator Nelson, for your interesting exchange.
May I say one more thing?
Absolutely.
I want you all to know that I had the privilege of flying in space. Pam Melroy, our deputy administrator, is here. She's a 3-time space shuttle astronaut. But there's something that's different when you look at Earth from the window of a spacecraft as you orbit the Earth. It's not only so beautiful and so colorful and so creative, and there it is, it's our home. I flew as a politician, and I saw something else, because as I orbited the Earth, I did not see religious division, I did not see racial division, and I did not see political division. What I saw as I orbited the Earth was that we are all in this together. We are all citizens of planet Earth.
Thank you so much. Thank you.
Thank you very much, Senator Nelson, for these inspiring words. And now we change again spotlight to the right side, and it's my great pleasure to welcome on stage the President of the Japan Aerospace Exploration Agency, JAXA. Clay, the word is yours.
Thank you, Christian. Dr. Yamakawa, thank you for joining us here today. Let's talk about from last year to this year. What are some of JAXA's, let's say, most interesting developments over the past year?
Okay, it's a really great pleasure to see you again, Clay. And well, this year is really a busy and also at the same time fruitful year for JAXA. I always say busy is good. And for example, this January, JAXA's lunar lander called SLIM successfully landed on the surface of the moon with pinpoint technology. And pinpoint technology means precision within 100 meters. So that's, I think, a great milestone for us to the next steps. And in February, we have successfully launched the second flight of our H3 rocket. That was a major milestone for us because we are at the transition phase from our H2A operational rocket to H3. And so the success of H3 number 2 was a great milestone for us. And also in February, as part of our JAXA's commercial debris removal mission, Astroscale of Japan have launched its satellite called ADRAS-J to conduct rendezvous and also proximity operation of the target space debris. The target means that we are trying to actually remove that space debris from the orbit in the near future. And in April, the government of Japan and the United States have signed the implementing agreement concerning the lunar surface activity and utilizing the pressurized rover. And JAXA will develop and provide manned or crewed pressurized rover. And at the same time, we will have 2 flight opportunities of the Japanese astronauts on the surface of the moon. And also this May, we have jointly developed EarthCare, as already explained by Joseph. And that was really a great achievement in terms of our Earth observation program. JAXA has actually provided one of the sensors on board EarthCare. And finally, I would like to say this July, H3 rocket number 3 launched successfully our ALOS-4 satellite, which is an Earth observation satellite with radar technology. So a lot of things happened.
Some amazing achievements. Dr. Ashbacher talked a bit about European sustained access to space. Can you talk a little bit about it from a Japanese perspective? How does H3, let's say, keep that capability relevant?
Well, from technology point of view, it's very simple. Testing, testing, and testing. That's it. But at the same time, I would like to thank the Japanese government and also our commercial partners to greatly support us to develop the next generation launch vehicle H3. And the good thing is that just recently, both Eutelsat Group and also UAE Space Agency have press release that they had an agreement with Mitsubishi Heavy Industry, who will be at the prime contractor of H3, that will have a signing agreement in terms of the launch service utilizing H3. So I think that H3 rocket will have international competitiveness.
Fantastic. You mentioned ALOS-4, this mission. Can you tell us a little bit more about that, Earth observation? But what's
ALOS-4?
Yes. Okay. What's the objective for this?
Yes, ALOS-4 is our it's a radar Earth observation satellite with beam forming technology, and the purpose of ALOS-4 is to contribute to disaster monitoring or disaster response, and also environmental observation and also maritime observation. So it's very important for our daily life, and the data of ALOS-4 is not just used for internally in Japan, but also contribute to the international community by providing disaster satellite images of the devastated area.
So we're here at this conference with the theme, responsible space for sustainability, and we're talking a lot about this. Asked the same question to Director General Visa. How does JAXA look at sustainable space? You mentioned Astroscale as a company that's looking at this. From an agency perspective, how do you view responsible space?
Well, I think sustainability is the key word for space, for our space activities, not only for Japan, but also for everybody in the world. And for example, the recently developed H3 rocket has its controlled reentry capability to not produce more, space debris. And of course, in order to avoid collision, we are engaging in space SSA, space situational awareness for decades. And also, we are, as I mentioned, collaborating with our private sectors to actually reduce the number of space debris in the near future. So that means the active space debris removal. But also, I said three things in terms of from a technological point of view, but also I think it's very important to contribute to a kind of rule-making or guidelines, because both rule guidelines and also technological point of view, those two are necessary for moving forward for sustainable use of outer space.
Very good. So I was in Tokyo this summer. I got a chance to see you there for the Space Tide conference. Yeah, my pleasure. Space Tide and Secure World Foundation did an event there. And everyone was talking about this, this fund that the Japanese government is now investing quite a bit of activity. You know, there's a discussion here about how do we get space investment going in a lot of countries where the model in the past has been more, say, traditional government funding, and now you guys are taking a different approach. Can you talk a bit about this, this fund and what's going on?
Well, yes. I think space is very important for our daily life and also for space environment and also for improving international collaboration in the near future. So the Japanese government decided to establish a new funding, what they say, or what we call Space Strategy Fund. And right now, we means JAXA is responsible for operating the Space Strategy Fund. And that means that we are becoming very busy right now. But anyway, we are very glad that we can contribute to, our commercial partners or academia, because those funds are not for JAXA, of course. Those funds are for our commercial partners and academia.
Okay. I've got a couple questions on here from Slido for you. One is about collaboration with lunar payloads. So you can talk about going to the moon, and you mentioned the landing, the precision landing. Is there room for collaboration with JAXA and other nations on lunar payloads?
Well, thank you very much. First of all, I would like to mention about our collaboration with India, ISRO. And we are right now collaborating in the mission called LUPEX. JAXA will provide the rover, and India will provide the lander. And so we're going to collaborate based on our, strong points, I would like to say. So I think there's more ambitious programs to come, but I cannot talk about it in detail today because it's not yet finished. The investigation is not yet finished, but there's still a great amount of room for further collaboration with our international partners.
Okay. I have another question about JAXA's involvement in the Artemis program. We saw the...
Thank you very much.
Yeah.
Artemis program is a really exciting program, and we would like to contribute to Artemis by, first of all, providing the ECLSS system to ECLSS environmental control and life support system, and we'd like to provide ECLSS system to the International Habitation Module, IHAB, and also we would like to provide cargo transportation function to the gateway of the lunar station, because we have accumulated our experience for the International Space Station program by providing HTV functions to the International Space Station. So, and finally, I would like to say that, as I mentioned, based on the agreement between the United States and Japanese government, we would like to develop a crewed pressurized rover, and that will the size of a small bus, and the 2 astronauts will be on board the pressurized rover. And of course, it can be also operated without astronauts. So anyway, so the pressurized rover will serve as a station on the ground and also to provide mobility on the surface of the moon. So I think that pressurized rover will be a great contribution in terms of the sustainable exploration on the surface of the moon.
Very good. I have one final question here about commercial LEO destinations. So NASA's already planning on what to do post-ISS. JAXA has some interesting capabilities. You mentioned HTVX, which is a very, very capable cargo system. How does JAXA think about post-ISS, where we're going, and what the Japanese contribution could be?
Well, thank you very much. I mean, it's not easy to say something about that because we're still studying various possibilities. But I think we understand that the post-ISS will be LEO will be a place for commercial activities. So LEO economy will be vital for the next generation. So we are thinking about how to collaborate with our commercial partners in moving on to the next stage. So that's the current situation.
Okay, well, thank you very much. Appreciate you joining us.
Thank you very much.
Thank you very much, Dr. Yamakawa. And we switch spotlight again to the left side. And it's my great pleasure to welcome on stage Dr. Somanath, the chairman of the Indian Space Research Organization, ISRO. Tanya.
Thank you, Christian. Welcome, Dr. Somanath, and let me first congratulate you again on the important award that was given to your agency this morning, the World Space Award for the exciting Chandrayaan-3 mission, only the fourth country to reach the moon and the first to reach the South Pole of the moon. Could you speak to the audience about the ongoing Indian missions? What's next? What is going on in your plans?
Thank you so much for that blessings that you have given through our team, ISRO, for that great mission, Chandrayaan-3. It's a journey that we started in 2007, as I mentioned in the morning, and we would like to continue the program of going to moon with a series of missions to moon, possibly with a view to have a capability developed, ultimately landing humans on the moon by the time 2040. But we have announced recently many missions, especially in the domain of exploration. Chandrayaan-4 is announced as the mission to go to moon and bring back samples. We also announced a mission to go to Venus as an orbital mission now, possibly with a capability to put a probe into the atmosphere of the Venus. You know, Venus has a very thick atmosphere, and going down to the surface is really challenging, and we are looking at how we can do that. We also announced building a space station. The very first part of the module of the Bharati Antariksha Station has been announced, which we would like to launch by 2028. And also we announced a building of a new rocket to do that at a later point in time. So these are some of the futuristic programs, but by the time that we do that, we have a series of Earth observation satellites. We are also working on climate and other related observations to help the issues of sustainability and climate change to be addressed, especially to support the national programs related to sustainability on Earth, of course.
Exciting. There's a lot ahead. I can see another World Space Award coming. I also recall that as ISRO chairman, you recently announced the intent to also launch a program, perhaps a bit similar to what ESA DG announced. It's called debris-free space missions. Could you tell us about that? What does it mean and how does it address sustainability?
I think as all of us were discussing this issue of sustainability in space goes with a cooperative work of maintaining space cleaner, though there is no way that we can reduce the number of spacecrafts, but then we should actually reduce the non-functional spacecraft and also creating additional debris from launchers as well as from other disposables. So this program of debris-free space mission is for all stakeholders in the space program of India right now, both the national space actors as well as a private ecosystem that is coming up, which will be authorized by the InSpace. So all of them were asked to maintain the zero debris emission principles, where we ask all the spacecraft at the end of its life to be deorbited, as well as they don't create debris through functional systems like the pressurization and other propellants that are left over. We also insist that the launchers will have capability to passivate them or deorbit them in the due course. Not only just for this part of it, that we look at the human space flight mission as a very critical capability that many nations are going to develop in the due course. So that zone where humans are going to stay, the 400 kilometer plus or minus 30 kilometer, must be preserved to maintain as a very clean area And while we plan orbits for missions, that we must make sure the transitioning through that region should be minimized so as not to cause harm to the human spaceflight missions. We also should work on other issues related to frequencies and orbits and sustainability in a big manner. So this is something that we have proposed in the 42nd IADC conference, which happened in India recently.
Wonderful. So, and is there also a specific timeline to this, like 2030?
Yeah, we have brought out the timeline where this will be implemented in full force by 2030. Yes.
Good. So we see some convergence, which is really, I think, heartening. Now, you've made reference already to the changing ecosystem in India. Obviously, you have opening up of the market, commercial companies coming, perhaps also foreign ones. How is that going, and are they also going to be held to these sustainability goals that you just outlined?
See, as you mentioned, I'll start from the point of sustainability. I think this sustainability has two elements: one, sustainability on Earth as well as in space. But with the emerging actors after the space sector in India has been opened out, I think there is a huge increase in the interest in private companies to work in space. Today, we have almost 200 startups and companies who are into space, building small rockets, launchers, building satellites, as well as deploying applications. I think this is a great thing to happen. We also brought out a new policy, the space policy in 2023, and also we brought out a new foreign direct investment announcement, and we also brought a geospatial policy of data sharing for especially dealing with the huge amount of data that our Earth observation satellites have been collecting over the years, how to make it available to stakeholders and make value out of it. I think all these have created huge interest in the space ecosystem, and we are also trying to collaborate with other space nations in a big way through the front-end organizations that we have, not only the ISRO, but the InSpace, as well as the New Space India Limited, which is the public sector undertaking, through commercial activities, as well as by industry connections. I think all of these are really creating a real buzz in the ecosystem in India today. And we look at space manufacturing as the key area, domain that we would like to develop in India in due course of time.
That's also exciting. And you also mentioned cooperation with other agencies, and JAXA president also referred to that. Could you say a bit about what you're doing in terms of cooperation with other agencies on projects?
No, there are many. I think we have agreements with at least 66 nations, agencies, who are working in space. Indian Space Research Organization has that many. But then some of the important and interesting ones are the one with NASA. The NISA is an interesting spacecraft that we are building together, a synthetic aperture radar in 2 bands, and we're hoping that this launch will happen early next year, which is going to cover Earth in these L and S bands in every 12 days, which will give us a lot of information related to the Earth, climate, etc. We are working on a spacecraft called Trishna, which is a thermal imaging satellite, with CNES and India collaborating on this critical thermal imaging of entire Earth, which is again very important for agriculture and climate related, and also the weather impact on various issues on surface. We have, as you already mentioned with the JAXA, we are discussing on the future lunar program, and with the ESA and many other stakeholders in Europe that we have connections and collaborative work in the past, and it's continuing.
And you're also a signatory to the Artemis Accord.
Of course, that we have been a signatory in the last year, and we started our engagement with all the Artemis signatories, yes.
Wonderful. I'm looking at a few questions that are coming up on Slido, and one of them is how and when will India enter into the human spaceflight domain? You made reference to the plans for a space agency. Maybe you could elaborate a bit further on that?
See, we started the human space program long back with our only one astronaut in India we have, Rakesh Sharma, who flew with Senator Nelson. They trained together. They are the good friends. Yeah. So we are looking at creating the human space program. We call it Gaganyaan. This program started 4 years back. And this coming year, we will be having the first unmanned mission with the crew module and stuff, all of that. Then followed by 2 more unmanned missions, and leading to the the crewed mission by 2026. That's our timeline now. But recently, government announced its continuation of the program. And we are also having a joint mission to ISS. Two of our astronauts are undergoing training at US now for a mission to International Space Station along with the European colleagues. And that will be something that we are looking for a collaborative mission. And we would like to continue this program. At least 4 of such missions have already been announced by the government. So we are developing most of the technologies in India, but it's a painfully slow process of developing human spaceflight capability. I'm hoping that all of this will come through very well coming days.
Of course, yeah, it's complicated because you want to bring them back home as well as sending them into space.
That's the challenge, yes, of course.
That's the challenge. Another question is about rockets, and a question is about whether India also has a roadmap towards reusable launch systems. And of course, we saw again the great achievement that happened in the US yesterday. Are you working on this? Are you thinking of that?
Yes, of course. I think all of you realize that reusability is mandatory for launchers. And it's just not for sustainability part alone. It's a principle is cost reduction. The access to space has to be affordable for us to expand the space program. So we are looking at our new launcher. We call it NGLV to be developed with the reusable capability of its booster. So the key technology for it is a throttleable engine. We are developing a LOX methane-based throttleable engine in India. And we hope that using that engine, we should be in a position to do this rocket development in another 6 years of time. So that's the timeline we are set for it. And also, we have already the stage technologies for the upper stage, which is the cryogenics, currently used in our heavy launcher, the LVM-3. So that will be scaled up to fit into this launcher. So with a new single engine development, we should be in a position to build that rocket, which will have something like 30 tons to LEO capability. Yeah.
Impressive. And maybe a last question, you also referred to plans to go as far as Venus, I think you mentioned. Are there plans also on developing nuclear propulsion? Senator Nelson also mentioned this, maybe as a possibility to go to Mars in a reasonable time frame. Is this something India is also looking at?
See, all of you realize that nuclear propulsion is something that can be used only for interplanetary travel. It's not something that comes into handy for missions from Earth. So, and we have a matured nuclear capability in India with its building of plants and other compact reactors. A long-term vision is already set for it. We are working on it, but then it's not immediately visible, the availability of such an engine and its use, yes.
Okay, wonderful. Thank you so much, Dr. Somanath.
Thank you so much.
Yes, big thanks to Dr. Somanath, and we are switching spotlight again to the right side. It is now my great pleasure to welcome on stage the President of the Canadian Space Agency, Lisa Campbell. Clay.
Merci, Christian. Bienvenue.
Bonjour Clay, comment ça va?
Ça va bien. I know she always likes to open with French, so I try to help. I try to help a bit. Look, we've talked a lot now about international projects, cooperation, what agencies are doing. This has been a cornerstone of the Canadian Space Agency's efforts over the past year. Tell us what's coming up. What are you guys working on with the other agencies around the world?
Thank you so much. It's wonderful to see everyone, so many friends and colleagues. International collaboration is in our DNA at the Canadian Space Agency. It allows us to focus on our strengths, but also to achieve incredible things with our partners. By working with others, we've been able to build areas of expertise, but also be part of extraordinary missions, and that makes us proud, and it also challenges us to go even further. We also aim always to be that trusted and reliable partner, so even when we run into problems, we continue to strive for excellence and then deliver on time, on budget. So from space exploration endeavors like the ISS, with Canadian robotics providing key services on orbit for almost 25 years, and the arm now doing things that were never foreseen. We just celebrated our 50th cosmic catch, where the arm catches incoming spacecraft and brings them safely into station. To the James Webb Space Telescope, an international game changer in astronomy, which continues to revolutionize, as others have said, our understanding of the cosmos. The SWAT mission, led by NASA and CNES, providing new and detailed information on the Earth's water, critically important resource worldwide. And for the past 45 years, Canada has had the honor to be a cooperating state and member of the European Space Agency. This partnership gives Canadian companies unique market access, which we're really proud of, and it helps them grow. I'll give you some examples. Canadian company SB Quantum has been awarded a contract by ESA to assess the viability of quantum diamond magnetometer, a satellite-mounted technology that shows promise in helping to monitor magnetic storms, which we're seeing more and more of. SB Quantum was also formed following our Canadian CubeSat program, which gives them hands-on expertise designing and launching real satellites. Another example is Seacor, a Canadian company on the east coast of Canada, partnering with ESA on their biomass mission. They'll design and build a transponder that'll help deliver crucial information about our forests, how they're changing, and the role in the carbon cycle. And then lastly, Canadian company ABB will provide a laser unit that'll be part of ESA's 9th Earth Explorer satellite mission. And the data collected will help evaluate how the far infrared part of the electromagnetic spectrum affects our climate. So this level of collaboration with ESA is possible because we're aligned. We're aligned in our vision of leveraging space for the benefit of humanity. We deeply value these partnerships. They're really important with established players, but also we welcome new partnerships. For example, we recently had the privilege of helping the Philippines with their first ever space conference. We also participate in multilateral fora, some of which are in collaboration with the United Nations. We recently hosted the Space for Women expert meeting in Montreal last year, building the tools to make sure everyone can be part of the space sector. And the Artemis Accords, which we've heard lots about, are perhaps one of the best recent examples where under US leadership, we're developing a common set of principles for how we go forth into deep space peacefully and sustainably for the benefit of all. We're strong supporters of the Accords. We'll be at a workshop in a few minutes to really advance what does this mean concretely? How can we operationalize these principles, which everyone agrees with, but what do they mean in practice as there are dozens and dozens of missions planned towards the moon? So fundamentally, we believe that collaboration makes all of us stronger. It's part of our history and definitely part of our future.
That's fantastic. What an amazing set of programs you're working on. Let's shift gears for a second, talk about deep space exploration. You guys have been contributing to that for some time now. What's the interest there for Canada?
It's fascinating to see that public space agencies around the world, having been present for a quarter of a century in LEO, we're all now focused on deep space. There's some really exciting opportunities for us. So we'll play a key role in humanity's return to the moon with critical technologies like Canadarm3 for the Lunar Gateway. Yes, who shouted out there? Some Canadarm3 fans. A robotic system that will use cutting-edge software to perform tasks around the moon without human intervention, maintaining Gateway when astronauts aren't present. A science rover designed to contribute to the search for lunar water ice. A lunar utility rover to support Artemis mission operations and logistics on the surface of the moon, and Canadian experiments and technologies designed for lunar conditions aboard the Gateway. And not to mention a historic crewed mission. Canada is so proud that our Canadian Space Agency astronaut colleague, Jeremy Hansen, will be on he's going to build on a proud 4-decade-long legacy of Canadian human spaceflight. We just celebrated 40 years from the first Canadian, Marc Garneau, who was in space. And now Jeremy Hansen will be part of an international crew on Artemis 2, making Canada the second country to send an astronaut around the moon. And for us, Clay, this is just the beginning. We think that the demands and challenges of deep space exploration are going to push us to innovate in a number of ways. So we're doing work in deep space food production, like many countries, because we think that this is something that can benefit us here on Earth in remote areas, but also in space as we send humans further into the cosmos, and healthcare. In both those areas, it's areas that our government is already investing in, and the hard environment of space can make it better. So I'll give you a concrete example. We awarded contracts to 5 companies to build connected care modules, and essentially they're the size of a shipping container and have everything you need to diagnose, treat, prevent illness, and then perform interventions to keep people healthy in remote locations in space and on Earth. We're working with the UK Space Agency. They've integrated an exercise countermeasure device into one of the designs, and ultimately this is going to be offered into low Earth orbit and remote parts of the country. So our lunar portfolio is strategic. The areas where we've built robust expertise have allowed flagship contributions, and as we look to the future, We want to carve out those niche areas that everyone is going to need so that we can be that trusted partner.
Great. You know, a couple of years ago, we did our first ever IAF conference on climate change with space. And so we did this in Oslo, Norway. Up north, there's a lot of issues now with melting ice caps, with the changes in the sea lanes up there. You've got, you know, billions and billions of hectares up there that are being affected by climate change, right, as the Earth is warming. Can you talk to us a little bit about CSA and what's your perspective on climate change and where you guys see that heading?
Definitely. So like for so many of us, using Earth observation data to help build a cleaner and greener future is a priority for the Canadian Space Agency and for the Government of Canada. We all see the effects of climate change. They're intensifying. The last 2 summers brought the most extreme wildfires that the country has ever seen. We're on the front lines of that issue, and we recognize that the knock-on effects of these blazes are not only in our country, the smoke spills across borders, and the temperatures are continuing to rise globally. So our northern communities are seeing that. It's actually impeding their access. Ice roads that used to allow them to transport goods and supplies just aren't there anymore. So weather's becoming more extreme. In Canada, we're fortunate to have a massive country with a relatively small population and a varied landscape of coasts, mountains, plains, forests, thousands of lakes and rivers. But each of these has a delicate ecosystem and a stunning biodiversity that we must protect. The issues we're facing are real, the urgency is real, and we recognize that satellites, with their unique perspective, are the best tools. If you're serious about managing climate change, you need your eyes in the sky. So since the mid-90s, our RadarSat system has helped us in this regard. RadarSat, RadarSat-2, and now RadarSat Constellation mission have all been invaluable in observing our country and our planet. And what's wonderful, Clay, is it helps build those partners across government. There's 40 services to Canadians that depend on these satellites, so we have more and more government partners coming to us and saying, please, can we use some of this satellite data? And that's helpful when it comes to seeking budgets and longevity for these. So last year, our government announced funding to support the development of a replenished satellite to keep the constellation of 3 going for as long as possible, and then to start work on the 4th generation program that'll go on beyond that. We are also working on WildfireSat, a dedicated satellite that's going to help us more efficiently manage wildfires, determining their peak burn time so that we can protect people, communities, and infrastructure, and effectively use those precious resources of firefighters and water when they're most needed. But we can't do it alone. Climate change is a global issue. It demands global solutions, and it means sharing data, but also sharing missions. So we are joining forces on the High Altitude Water, Vapor, and Clouds, or HAWK mission. It's Canada's contribution to NASA's lead atmospheric observation system with JAXA and CNES. So it consists of 3 innovative instruments and 1 satellite, and it will give us critical data to support extreme weather prediction. I mentioned earlier SWAT, but it's also not just about launching satellites, it's about maximizing the return on investment from the data. So we're pretty passionate about that. We are starting a pilot project called Digital Earth Canada to push out open data that everyone can use in an accessible way and create new businesses, but also help with analytics and modeling. Because as much as we can do at the macro level, it's truly about what does it mean for me in my community on the ground? How is this data relevant to me? And it's incredible what we can witness when you give that data to people. It helps us coexist with the flora and fauna around us. So to close on that, biodiversity is one of the main topics this year at the Plenary of the Committee on Earth Observation Satellites, also celebrating its 40th anniversary. We're proud to chair it, and the meeting is next week at our headquarters.
Super. You know, I've had some questions on Slido, but it actually represents one of the questions I have here, my last question here for you, which is, look, at the IAF we have 3G Diversity Plus, and that's gender, geography, and generation. If it's okay, I say you're the only woman here on the platform. Tanya, no offense, but the only space agency leader woman here on the platform today. Can you talk a little bit about what, yeah.
Thank you. Hang on, we're going to do something fun. Perhaps that the people who identify as female in the crowd could stand up, if you're able to.
Please.
There we go. There we go. There we go. Oh, wonderful. So, I'm just going to stand up for them. Salute you.
So, So as an industry, we've struggled a bit, right? Because we don't have as many women represented. Can you talk a little bit about underrepresented populations in our industry and what CSA is doing to address it? How do you think about it?
Yeah, well, you know, I think about the panel that we had earlier this morning that talked about the ways in which we present data, which is limited to visual, and it should be multisensory. Surely, if any sector can figure out that you need to get rid of barriers so that you can bring in all of the ideas, it should be the space sector. We should be working so hard to remove all of the barriers so that everyone can be part of our magnificent adventure, because we're facing hard problems. We're going to have a reckoning soon when it comes to space sustainability. We've created a huge problem for ourselves that is going to make it difficult to use space infrastructure, and it's urgent. So at the CSA, we're working hard on this, and we've made some strides, but it's not only at the agency. We also want to change the space sector across the country and hopefully have an influence internationally. We hosted Space for Women, as I mentioned, in Montreal. That we did with the United Nations, and we've created a toolkit that any country can use to help increase representation so that we're actually representing humanity as we go forth into the cosmos. We want those brilliant and diverse minds. We need you, and we actually recently published a funding opportunity focused on increasing equity, diversity, inclusion in the space sector, and the results show great promise. I view it as a huge opportunity as well, Clay. The first projects funded have been a STEM internship opportunity for post-secondary students of underrepresented groups to advance their knowledge of space health research, a space competition specifically for women and Black post-secondary students, and tailored space education activities for post-secondary students that are underrepresented in the space sector. But all of this, Clay, goes back to inspiring children, you know, so that when they're 5 years old, wherever they are, they can see, I can be part of this, I can be part of the space sector, I see myself, or I know that it's possible for me. So we do a lot of outreach across the country, in the north, in indigenous communities, meeting children where they are, making sure that the tools we provide means that they can explore, dream, be part of the magnificent space adventure. Our goal is to ensure that future generations can study and contribute to the global space sector and push humanity forward in so many ways.
Thank you. That was very helpful.
Thank you. Thanks, everybody.
Thank you very much. And we change again spotlight for the last time of this plenary, and it's my great pleasure to welcome on stage Mr. Li Guoping, the Chief Engineer of China National Space Administration.
Welcome, Mr. Li. Now we see something beautiful here on the table, and we're all very curious what this is and very excited that you tell us what we are seeing. What are we looking at?
应大会组委会的邀请，我今天呢给这次大会和展览带来一个特殊的一个展品。
So it's invited by the exhibition organizers. I'm actually taking the very special exhibition for the IAC Congress and also the exhibition here.
大家看到的目前这个展品是一个类似于中国元素的一个工艺品。实际上，在我们这个圆形器皿里镶嵌的是我们刚刚带回来的月球背面嫦娥6号带回月球背面的样品，月球样品。
So it looks like some kind of artifact with Chinese culture inside, but actually it contains some of the samples we get from the far side of the moon, from Chang'e 6 mission.
今年5月3号，我们中国发射了嫦娥6号探测器，在6月25号，探测器这个携带了月壤顺利返回地球，一起采取的是月球背面的月壤1935.3克。
So in the May 3rd of this year, we successfully launched the Chang'e 6 spacecraft into the lunar orbit, and then in 25th of June, we have the return capsule returning the lunar samples. It's around 1,935.3 grams of lunar samples.
这次采回了月球背面的样品，包括从月球表面采取的样品，还有通过钻起的方式获取的这个地球深处的样品。
So the lunar samples contains the sample we gained from the surface of the moon, and also by the digging mechanisms we get from in depth of the under the surface of the moon.
我们这次长高6号任务啊，还很荣幸搭载了来自于伊萨、法国、意大利和巴基斯坦的载荷。
And also this mission contains some scientific payload from ESA, from France, Italy, and also Pakistan.
中国的科学家对这个采回来的月球背面的样品啊进行了初步的分析，认为我们背面的月球样品同月球正面的这个月球样品相比，在结构或特征方面有明显的不同。
And the Chinese scientists already conduct some initial analysis of the samples we gained from the Chang'e 6 mission and find some differences between the samples we get from far side and the near side of the moon in terms of the structure and also characteristics of the samples.
我们这个样品呢会摆在中国展区这个国家航天局展区里面，大家可以有兴趣可以参观。
This exhibition, this sample will be put into the exhibition room of the China Space Area this time in the IEC. Welcome you to visit our booth there.
关于这个月球长高6号样品的一些详细的情况，我们明天下午的5点45分，也在这个会议室，按照组委会的安排，我们将对这个样品有一个专门的介绍，欢迎大家来了解相关情况。
So for specific information regarding the lunar sample for Chang'e 6, there will be a specific event tomorrow, and also in the same place, as invited by the organizers of IEC. So welcome you to come to join this event, and we will elaborate more about the lunar Chang'e 6 and its mission we get from the samples.
Exciting, congratulations. This is really amazing achievement, and we're very grateful that you brought this to us here in Milan. Thank you for that. Yeah. And it's maybe hard to look ahead what's next, but could you tell us also a little bit about what are the coming plans, other plans and missions that China is planning in the near future?
关于未来几年的中国航天的发展规划呢，我想简要的做一个以下的表述啊。
So I'd like to elaborate in a few points regarding the plans of China Space in the next few years.
我想首要的呢，可能还是要完成好我们自己关于在月球和行星探测方面的任务。
So the first of all is to conduct our missions regarding the lunar exploration and planet exploration.
首先是嫦娥7号的卫星的任务，探测器的任务，预计在2026年来实施，将降落在月球的南极，主要目的是寻找在月球南极有水冰存在的这些证据。
The first mission, the next mission will be Chang'e 7, which will be launched around 2026. Will be landing on the south pole of the moon, and the main purpose of the mission is to find the evidence of the water ice.
嫦娥8号任务呢，也是我们正在开展的一项任务，预计在2028年前后的实施。这次任务呢，也将着陆在月球的南极。
And the next mission will be Chang'e 8 mission, which is under demonstration, and we're planning to launch that by 2028, and also will be landing on the south pole of the moon as well.
我们在去年的宇航大会期间宣布了嫦娥8号将搭载我们国际同行有200公斤的载荷搭载机会。目前呢，我们这个国际搭载载荷的任务正在选取确定过程当中。
Last year in IEC in Baku, actually China CEST announced the possibility to launch SP-drive payloads from international partners around 200 kilograms as a scientific payload on Chang'e 8. And now the process of selecting the Chang'e 8 international payloads is still ongoing.
另外呢，我们中国的载人登月的任务也正在实施过程当中。我们计划在2030年前，中国的宇航员将登上月球的表面。
And China's manned mission to the moon is also under implementation, and the target is to by 2030, Chinese astronauts will be on the surface of the moon.
在这个任务同时呢，我们正在开展的一项重要任务，就是推进作为这个实施国际月球科研站计划，也就大家看到后面这个屏幕的相关任务，这个任务正在认证过程当中。
And in the same time, we are conducting feasibility studies and analysis for conducting next missions to the moon, which is International Lunar Research Station. You can see on the screen right now.
另外，我们还正在组织实施行星探测计划。我们计划在明年2025年将发射我们中国的天问2号行星探测器，将从小行星上进行采样返回。
And apart from that, we are also conducting missions to other planets for the exploration. For example, like in 2025, we're planning to launch our Tianwen 2 mission to collect the samples from the asteroids.
下一个任务呢，就是天问3号任务。计划在2028年，我们中国这个火星探测的第2次任务将发射天问3号到火星表面着陆。 并在火星采样返回。
And the next mission will be on 2028. We're going to launch Tianwen 3, which is going to the Mars. It's the second mission of China to the Mars, and that will be have the landing and also the sample return for the Mars.
在这个地方，我也给大家报告有一个好消息，经过中国科学家的精心的设计，目前我们在天问3号任务的火星轨道器上。 可以给国际投行预留25公斤的搭载机会。
And also good news for the audience here, actually is designed and also analyzed by Chinese scientists. We have also reserved some capacity for international participation, especially on the orbiter of the Tianwen 3 mission, which has around 25 kilograms of payload capacity for international partners.
另外呢，还有一个在服务器上，可以有5公斤的搭载机会。
And another 5 kilograms on the surface module of the Tianwen 3 mission.
中国的天问4号任务主要是对木星及其以远任务进行探测。我们计划在2030年实施这次任务。
The next mission for Tianwen series will be Tianwen 4 mission, which is targeting the Jupiter and the further areas in the solar system. That program will be launched around 2030.
我想中国航天任务的另外一些配合这些重大任务呢，就是关于可重复的重型运载火箭的发展。我们预计在2032年前后，中国的重型运载火箭将实施发射。
So a very important element for these missions to be successful will be the reusable heavy launcher, and we are in progress to develop such a launch vehicle, which will be targeting at around 2030 for the maiden flight.
另外呢，我们正在积极完善中国的卫星技术的防灾减灾体系。那么在未来一段时间，我们还要发射海洋盐度卫星以及其他的一系列的新的探测卫星，完善中国的防灾减灾技术体系。
And other aspects, including the missions to using space technologies to help perfect our capabilities in space for the disaster management and disaster mitigation. So satellites, including the Ocean series satellites for the salinity exploration, and the other new kind of satellites to fulfill this mission will be conducted in the following years.
再一个就是全力推进利用空间技术进行全球气候变化的研究。我们目前已经发射了专门用于监测二氧化碳的大气1号，测量大气陆地生态碳卫星，还有用于测量二氧化碳、二氧化硫的专用卫星。
And the other satellites, including the satellites to help tackle the issue of climate change, to have the atmosphere series of satellites, especially for the detection of the CO2. And the other satellites to have a mitigation of the carbon peaks and help measure the issues.
我们还会继续开发一些新的卫星，能够用于全球气候变化监测的卫星的系统，卫星的发展。也告诉了一个消息呢，明年的4月24号，也就是中国的航天日，我们将在上海举办一个专门的航天技术用于全球气候变化监测研究的这么一个专题研讨会。
So China will continue to develop new technologies with space technology to help tackle the climate change issue. And the update is actually we are organizing our symposium to using space technology on the climate change issues. That event will be held next year during China Space Day events, 21st of April in Shanghai, China.
第4个方面呢，主要是还是要开展空间科学的研究。 先跟大家报告一下，今年上半年6月22号，由中国和 CNES 联合研制的中法天文卫星成功发射。到现在为止，我们已经测到了40次的伽马暴。
And the first aspect is satellites for science, space satellites for science. So the satellite we launched together with France. It's in this year, 22nd of June, which is a swarm satellite. So the satellite has been launched successfully and up to now has detected over 40 times of gamma ray bursts.
后续我们还要继续发展一个关于太阳观测以及引力波探测等新型的不同种类的空间科学卫星。
And in the future, we'll develop new kind of satellites to explore for the purpose of scientific research, for the solar system, and for the sun exploration, and also like for the gravity wave.
Thank you so much. I think we could fill a whole session with all the impressive achievements of China. Obviously, congratulations to all these important steps your country is taking. It's truly impressive. I see the time has already elapsed, but I would like you to maybe comment for 1.5 minutes on ILRS. We see the beautiful graph here on the screen. Could you maybe expand a little bit on the plans of the ILRS? How is it going? We have many countries that have signed up to it. What are also the implications of this plan or the projects of this plan for sustainability? To just briefly bring it back to the theme of the Congress.
这个国际月球开源计划呢，中国已经酝酿推动有2年以上的时间了。目前有15个国家和2个国际组织已经签约加入了我们国际月球开源计划。另外呢，还有多个国家正在跟我们商讨加入月球开源计划。
So China has been inviting international partners to the ILRS mission, and up to now, around 15 countries and 2 international organizations have signed in the ILRS mission, and various other countries also study and also in the negotiation phase with China to join in this mission as well.
这个计划呢，也是一个长期的计划。我们预计分为2035年前建立一个基本月球开源的项目，这个工程到2045年能建立一个完善性的国际月球开源站。
So this kind of program is really definitely a long-term program. So our programs to be put into 2 phases. By 2035, we're planning to build a basic model for the ILRS, and by 2045, we have a more perfected extended model for the ILRS.
目前呢，正在开展国际月球开源站方案详细的论证工作。我们希望呢，我们成员国、参与国能够在不同层面可以参与的月球开源站项目，比如说参加整个卫星系统，或者一个单机，或者载荷，或者地面设备设施，以及其他的方式可以参与国际月球开源站的计划。
So we are currently in the stage of feasibility studies, very initial designs of the mission overall, and we work with international partners joining different parts of the mission in different levels, including, for example, like the system, some kind of system in the spacecraft, some kind of equipments or units, or some kind of scientific payload, or even ground infrastructures, other part of the mission, or they are all welcome to join in.
目前了解到呢，大家刚才知道了，我们在月球探测方面计划，国际计划还是比较多的，比如说刚才提到的阿尔特弥斯计划，还有其他的计划。为了在月球这个探测方面的可持续发展，我也提几个建议。
So actually, today we discuss about many missions to the moon, including the ILRS mission and the Artemis mission and the other missions from different countries. So to ensure the sustainable development and exploration of the moon, we have also some suggestions.
我们建议不同的计划之间要加强信息的共享。每个计划你的任务的目标、你的着陆的地点、时间等等这些因素要加强相互协调。
So first of all is to kind of information sharing for the missions to the moon. We hope all the countries involved in this kind of missions to share the information regarding the targets of the mission and the landing locations and the launch schedules of the missions.
第二个呢，不同的计划之间呢，我也建议加强横向的多边的国际合作交流，使得有很多技术、很多事情，很多技术可以进行共享。比如说，将来中国的宇航员是不是也可以进到其他的月球的月球基地
The second suggestion would be have more international cooperation and collaboration in the lunar exploration programs to share the benefits and also technologies for the moon exploration. For example, like in the future, for the Chinese astronauts, when they are landing on the moon, can they be entering the other space stations or space bases on the moon built by other countries?
第三个呢，我们建议在联合国的外汇委的框架下，不同计划之间，加强紧密协作，制定出比较完善的在月球方面的一些行为规则。
The third suggestion would be to, under the United Nations framework, the countries involved in the space activities on the moon exploration to have more collaboration and communication to build a kind of practices that widely accepted by all the members involved in such missions.
谢谢。
Sheshe, thank you so much. And I think those all make perfect sense. Cooperation, information sharing. Let's do it. Thank you so much, Dr. Lee.